Here we're going to have a look at 2004, question 4, part A. Alright, this is a nice little connected particles question. If we have a look in the diagram, simple, one pulley, two masses. Part 1 looks nice and easy, find the acceleration of the system. Part 2 looks a little funkier. So let's get part 1 out of the way and we'll deal with the second one then. So, first of all, we're going to draw a diagram, as we always would. So we have one mass, which is 2m, connected by a string, tension T, under the force of gravity, which is 2mg. Okay, then we have a second particle over here, mass m, so mg is its weight, and the same string, so it's T. A little bit of common sense will tell us that this one is going down, and this one is going up. So now that's our direction sorted out. Step 2 with all of these questions, always going to be F equals ma. Alright, so in this case we have 2mg minus T equals 2ma, okay, because 2mg is positive, T is negative in this case. In this case it's flipped around. This is their positive direction, so that's T. So T is positive, T minus mg equals ma. Alright, now it is almost always easier to deal with these in simultaneous equations. So pop that down here. 2mg minus T equals 2ma. And the reason it's almost always easier is because the T's cancel out dead easy. 2mg minus mg means we have mg equals 3ma. It gets even better. The m's cancel, so g is 3a, so therefore the acceleration is g over 3. Yeah, that's part 1 done, not too bad, under 2 minutes. So part 2 though is a little bit funkier. Now what we're going to do is part 2 we're going to come up here. Just there we are, part 1. Part 2. We need to stop and think what's going on. The string breaks at a certain speed called v, and we're interested in the distance when this happens. So if in doubt, we're going to draw a diagram. So there we are at the start. That's 2m. And that one there is m. Okay, so this is the start. Then at some point, we're going to have a break. Alright, now let's see what this looks like. Well, 2m has fallen. Okay, and we can draw like the level line that this is all happening at. 2m is down here. And m is up here. Okay, so let's look. The distance this guy has moved, it's called s. And because it's an inextensible string, m has gone up by s. Alright, now that's not exactly what we're being asked yet, but it's close enough. So what we're going to do is we're going to find this distance, and then we'll go back and check in our question. Of course, we're looking for the vertical distance between the two of them, so it's going to be 2s in our answer. Alright, and since the equation's in motion here, so let's see what we have. U is 0, v is v, acceleration is g over 3, makes sense, it's moving a little bit slower than it was falling just on its own. The distance, we're going to call it s. We're going to solve for this s for the moment, because we're just going to deal with one particle. Okay, this is any one particle. Technically we can just use either. And the time is unknown, with no information about time. So what that tells me is, looking at these guys here, which is our equations of motion we're going to use, is v squared equals u squared plus 2as. Again, always write it down, always tell your story of how you're going with this. Alright, so v is v, u is 0, it's 2, g over 3, s. Alright, v squared equals 2 g over 3 s. Now I've left s out because I know I want to find s, so it's just easier to deal with. So we're going to rearrange that, and I'm going to end up with 3v squared over 2g equals s. Okay, this is great. This is where a whole chunk of people are going to go fabulous and stop and forget that, of course, they were asked for the total distance here. Okay, total distance, and that is 2s. So therefore, okay, distance equals 2s equals 3v squared over g. And that's your answer there.